Hello and welcome to this lesson for Design and Technology, Grade 9. Today we will talk about mechanisms. In this video, you will be able to list different types of motion, understand that motions need to be converted from one form into another, and state examples of conversion of motion through mechanisms. What can mechanisms do? They can change the type of movement, transmit movement and force, change the speed of movement, amplify or reduce the distance of movement, change the direction of movement, and change the amount of force a movement provides. What are the types of movements we have? The first one is linear movement. It is movement in a straight line, for example, for a car moving along a road or a train. As such, linear movement can be represented by an arrow. The next is rotary movement, which is movement in a complete circle, for example, a wheel turning. It can be represented like this. The next is oscillating movement, which is movement backwards and forwards in a part of a circle, for example a pendulum or the mechanism given here. It can be represented as such. The next is reciprocating movement, which is movement backwards and forwards in a line. For example, the piston and cylinder arrangement given over here, which can be represented like this. Now, how do we change the type of movement? One method of doing that is using wheels. The wheels on a wheelchair rotate, but the wheelchair moves forward in a straight line. Rotary movement has been converted into linear movement. The transformation of the movement can be represented like this. We can change the type of movement using gears as well. Gears come in many different shapes and sizes. A gear is a wheel with teeth. It can be fixed to a shaft so that it turns at the same speed as the shaft. Here you see a gear A which drives a gear B. Gear A is the driver gear and gear B is the driven gear. Using pulleys and sprockets can also change the type of movement. A pulley is a wheel used with a belt that grips onto it. There may be a groove in the pulley to help the belt grip. A sprocket is a gear wheel used with a chain wrapped around it. The teeth on the sprocket fit into the gaps of the chain. In this fan, a crank arm rotates and changes rotary motion to an oscillating movement. This is an illustration of the mechanism used. It is also known as a 4-bar linkage. The small crank arm rotates. It is connected by a link to a lever which oscillates or rocks to and fro. This is often called a rocking arm. The fourth link is the base, which does not move. Mechanisms that transmit force or movement from one place to another are often called transmission mechanisms. In this muck spreader, the linking shaft transmits a turning force from the tractor to the spreader. The bicycle gives very good illustrations of transmission of movement. The chain on the bicycle transmits rotary movement from the pedals to the rear wheel. The cables transmit the pulling force on the brake handle to the brake blocks. Cranks make drilling and pedaling easier. Cranks are stiff arms fixed to a shaft so that when the shaft rotates, the arms rotate too. They are often attached to handles and are used to make turning and tightening easier. Levers are bars or rods that move about a pivot or fulcrum. Sometimes they are made in pairs to grip or crush something. Linkages are used to join different parts together so that they can move in a particular way. They are often connected with pin joints. You can use parallel linkages to make two or more parts move together and or stay parallel as the linkage moves. Parallel linkages keep the trays level when you open this toolbox. Pin joints allow free movement of the linkages. Mechanisms can also change the direction of movement. When you pull the rope, the pulley at the top turns and the load goes up. Mechanisms can also change the direction of movement by turning the axis of rotation through an angle. We have the example of a hand whisk over here. The axis of the gear wheel that drives the hand whisk is at right angles to the blades. This arrangement turns the movement through 90 degrees and is therefore a change in the axis movement. In these pruners, output force increases and speed decreases. The handles on these pruners act as levers. They are much longer than the blades. So, the cutting force that the blades exert on the branch is much greater than the force applied to the handles. Over here, we have an illustration of the use of gears to increase output force and decrease speed. A small force is used to turn the crank handle and produces a large force to stretch the net. Mechanisms can be used to apply and maintain a force. A simple example is the clothes peg, which consists of a spring and two levers. This exerts two equal and opposite forces which hold the clothes tightly against the washing line. Mechanisms can also be used to amplify or reduce the distance of movement. The diagram illustrates a pantograph linkage. This is used to copy and rescale shapes and drawings. An illustration of the use of a pantograph is as such. You can use pulleys to change the direction of movement as well. A pulley system changes a downward pull on the cord of this blind into upward movement of the blind. This escalator is a large chain and sprocket system. The steps are fixed to the chain. You can turn the axis of rotation by using a twisted belt. In this vacuum cleaner, the axis of the motor is at right angles to the axis of the rotating brush. They are connected by a twisted belt. This clockwork mouse contains a mechanism which increases output speed and decreases force. It uses a gearbox to turn the wheels much faster than the drive axle from the motor. The toy must be light because the moving force provided by the wheels is much less than that applied to the gears by the motor. Gear trains can also be used to decrease output force and increase speed. In this arrangement, there are 3 times as many teeth on the input gear as the output gear. When the input shaft turns once, the output shaft will turn 3 times. As a small exercise now, can you name 6 functions of mechanisms? They can change the type of movement. They can transmit movement and force. Change the speed of movement. Amplify or reduce the distance of movement. Change the direction of movement. And change the amount of force a movement provides. Now, which of these 2 mechanisms convert rotary motion to linear motion? Correct. Wheels convert rotary motion to linear motion. In this video, you had a look at how to list down different types of motion, convert motion from one form into another, state examples of conversion of motion through mechanisms. These are the references of images used. This brings us to the end of this presentation. Do remember that all our videos are available on the website of the Ministry of Education under the Student Support Program. Thank you for having watched this program. Do catch us for our next lesson on mechanisms. Goodbye.